On today's episode, a workable fix to decarbonize energy is here, and no one is talking about it. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. The UN Climate Change Conference in Glasgow is underway, and like all major gatherings where politicians are attempting to do what engineers can do better, very little will be accomplished in the end. Why? Because politicians and economists, like all craftspeople, know what they know, and they use the tools at their disposal to get the outcomes they want. Politicians and economists attempt to use the tools of legislation and money to allocate resources into areas that generate the results they want, in this case a decarbonized global energy system. Will it work? Well, probably not, and even if it does, it will do so at excessive cost and over a much longer time than would be necessary if experts handled the problem. Now, one solution that I expect no one in Scotland to talk about is micro-nuclear reactors. Nuclear could have been the solution to CO2 long before anyone was aware of the problem, but for 50 years the same environmentalists who are driving the global warming agenda today fought long and hard to stop the technology. Now, this made sure that the world's energy system was fueled primarily by petroleum. And as a result, even if they change their tune, the large-scale civil engineering projects that we call nuclear power plants simply can't be built in large enough numbers fast enough to hit any realistic CO2 reduction targets. But that doesn't mean that nuclear won't work. Quite the contrary, in fact, with a new generation of micro-nuclear reactors that use fundamentally different operating principles from the traditional water and movable rod moderator designs. Now, I won't go into the technical details here, and they are fascinating, but the key takeaway is that these new fission reactors are intrinsically safe. That means that they don't need highly redundant safety systems or emergency procedures to be made safe in the event of a problem. And critically, they don't need the heavy concrete and steel containment structures to contain radionuclides the way conventional reactors do. Better yet, they're scalable, but in the other direction, meaning they can be made small enough to be air transportable or truck transportable in a form factor similar to a shipping container. With outputs on the order of single-digit megawatts, the small units can be used almost anywhere, from the Arctic to remote communities to natural disaster zones in an emergency. They can run for up to a decade with minimal maintenance. At the end of their life, they're small and light enough to be buried deep in stable geological formations. Now, compared to CO2 capture and sequestration, or conventional alternates like wind and solar, microreactors have the advantage of working anywhere, anytime. And most importantly, their form factor means that they're mass-producible on assembly line principles. This means the standard engineering economics apply. Increased volume means lower unit cost. So why does this excellent solution receive so little attention compared to grid-scale and residential solar, photovoltaic, and wind energy? Well, in my opinion, it's because the same politically motivated people that are driving the CO2 agenda are the people that hobbled the nuclear industry in the 70s and 80s. And their lack of engineering knowledge and other more questionable political considerations means that they must throw shade on anything related to atomic energy. Now, engineering is about finding the most reliable, cost-effective solution to any problem. Environmentalism, as it's currently construed, seems to demand neither of these things. Microreactors, mass-produced with auto-assembly line principles, might be the key to energy in the 21st century, if politicians start listening to engineers. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.